Our last topic for this unit is dividing rational expressions. So again, let's go back and look at how we can do this with just simple rational expressions with just numbers, and think how we can then translate that to doing this with polynomial expressions. So when you multiplied, or excuse me, when you divided fractions, you actually did what? You multiply by the reciprocal. And so that's why my brain naturally goes through that multiplying, because it really is just another multiplication problem in disguise. So all we have to do is make sure that we've kind of flipped our perspective when we do those problems. So if we wanted to divide 2/3 divided by 1/2, we would really think of this as the multiplication problem of 2/3 times 2/1. And then we multiply straight across just like we did in our last lesson. So 2 times 2 gives us 4, 3 times 1 is 3, and we'd have 4/3. Same thing goes if we have any variables in our expression. So anytime you're dividing, you always multiply by the reciprocal of that second fraction. So really, x divided by 5, all divided by x/7 would really be x/5 times 7/x. But wait a second, if we're multiplying these, is there anything I could simplify out? Indeed, I actually have an x in common in my numerator and denominator, so I can simplify that expression out, and we're going to be left with 7/5. So it's the same thing we're going to do with any polynomial expressions. Rewrite it as a multiplication problem, and then just pick up with the same steps we did in our last lesson, factor everything out, and then see which factors you can simplify. So our first example, x plus y/6 divided by x² minus y² 3. So I can first rewrite it. So first expression, x plus y/6 stays put, but then we're going to multiply by the reciprocal of the second fraction. So 3/x² minus y². Now we're going to go ahead and factor our expressions like we did before. X plus y can't factor, but I know I'm going to be putting together my two expressions as one big rational expression to simplify. So I'm going to go ahead and write that as its own factor because he's by himself in his own denominator right now. Then we have a 6. In our second expression, we have a 3, again, its own factor. We have an x² minus y², but that's a pattern problem. I can factor that out to x plus y, x minus y. And now I have factors I can simplify out. I have an x plus y in both the numerator and denominator. And so I'm left with a 3 in the numerator, a 6 in the denominator. Wait a second. Could I have simplified any more? Well, yeah. 3 is a common factor with the 6. So if I simplify out the 3, I'll be left with a 2 in the denominator. And so now my expression will finally become, see, everything simplified out from the numerator, so I leave a 1 as a placeholder. In my denominator, I have a 2 and an x minus y. And again, sometimes you may see it written that way. Sometimes you may see it where we multiply out that denominator. So we'll have a 2x minus 2y. Either one of these would be a correct answer, because they are both fully factored and simplified. Alrighty, example 2, again, same thing. Let's rewrite it as a multiplication first. So 3n plus 6 over n² minus 9 times 4n plus 12 over 6n² plus 12n. And I always like to write these out first before I start actually factoring out. I don't want to try to do too many things at one step, because that's when I start making typos or lose track of what steps I'm doing. Do one task at a time. So first numerator, I can factor out a 3, leaves me with n plus 2. First denominator, I can factor out into n plus 3, n minus 3. Perfect difference of squares. Again, multiplication problem, so in essence, I can just write one big rational expression. My second denominator, I can factor out a 4, leaves me with n plus 3. And in my second denominator, I can factor out a 6n. Again, nothing wrong with putting your factors in parentheses. If it helps you organize, do it. Leaving us with an n plus 2. Everything is now factored, so let's look for common factors we can simplify out. We have an n plus 2, We have an n minus 3. And then let's consider our extra values. So I have a 3, which I could simplify out with the 6 to leave a 2. But then I still have a 4 in the denominator or in the numerator. I can now take this 2 and simplify with the 4 in the numerator, leaving just a 2 in the numerator. Okay, the only other thing I have written in is an n minus 3, no other extra factors I can simplify out with. So my final answer becomes 2 over n minus 3. Simplifies way down to a simple expression. Okay, example 3. And as always, if I'm going too fast on these problems, pause the video, rewatch it. You can slow me down even, you can change the speed of the video. Do what you need to do to make sure that you're understanding the steps. Okay, example 3. So again, let's write as a multiplication problem. So x cubed minus 27 over 4x squared minus 81. And I'm already noticing I'm going to have to use some patterns on this one. Reciprocal of the second fraction. So 2x plus 9 over 2x minus 6. Now factor out each expression. Our very first expression, he's a difference of cubes from 2 videos ago. Find your perfect cubes. So x and 3, square the first, multiply to make the middle, square for the last. Same sign, opposite sign, always positive. First denominator, 4x squared minus 81, he's another pattern, difference of squares. So 2x plus 9 and 2x minus 9. Okay, my second expression, 2x plus 9, I don't have any common factors I can factor out of that, so I'm just going to leave him as a 2x plus 9. And then my second denominator, 2x minus 6, I can factor out a 2, which leaves me with x minus 3. And now I can start looking for my common factors. Let's see, I have a matching x minus 3. I have a matching 2x plus 9, but that's it. Again, that x squared plus 3x plus 9, that came out of a difference of squares, difference of cubes. And so I actually can't factor that out anymore. I could try and I'd keep getting stuck. None of my factor combinations would work. So we are left with the expression then. We have an x squared plus 3x plus 9 in the numerator. In the denominator, we have a 2 times 2x minus 9. And we could leave them written out like that, or we can multiply our denominator back together to give us x squared plus 3x plus 9 over 4x minus 18. And again, it depends on your application. The reason I'm writing these as both possibles being the solution is eventually when we get to graphing, kind of second half of the course, we're actually going to want to leave things in this factored form. It's going to help us out a little bit better. But formally, if we're trying to give our completely simplified answer, we would probably multiply everything back together again. So again, it really depends on what application we're going to use our factoring for as to how we're going to leave our solution. So either one of these is fine. I believe, again, most of your test problems, I think, will be listed as being factored out. Okay, go ahead and pause the video and try example 4. Okay, let's see how you did. So rewriting 4x cubed and x cubed plus 64. I've got another one of those sum of cubes times x plus 4 over x cubed minus 4x squared. So that's really the only factoring pattern I have. Everything else is really just taking out a GCF. So first one, I can factor out an x cubed, which leaves me with 4 minus x. And there's the kicker. That's what's going to make this one a little trickier, but not too bad. First denominator, again, perfect cubes. And then square, multiply for the middle, square for the end. Started with a positive, so same, opposite, always positive. Second expression, nothing we can do from that second numerator, so I'm going to leave it as an x plus 4. Second denominator, I can factor out that x squared again, leaving me with an x minus 4. And so we are almost ready to simplify, except what kind of trick do we have to apply? So we've got our x minus 4 compared to the 4 minus x. Again, we can't cancel them directly because the signs technically are flipped. So I'm actually going to factor out a -1 from that top factor. I'm actually just going to go ahead and rewrite them. So -1 times x minus 4. And now I can simplify things out. So I have -4 cancels with x minus 4. I have an x plus 4 that cancels. I have an x cubed and an x squared. So if I simplify out the x squared, I'm left with just a single x. And so let's write out what we have so far. So we have an x times a -1, which I should probably multiply in my final answer. And then I have the x squared minus 4x plus 16, which again, because he's the result of sum or difference of cubes, I know he's not going to factor anymore. So I would definitely write this one out as a -x. It's a lot cleaner to write it that way. Not incorrect the first way of writing it out, just a slightly more elegant way of writing it. So the only other problems that we need to check out are really just another way to write a division problem, but they're still just a division problem. So as we look at our second page, oops, I need to save. And now it'll let me scroll. That looks like a big honking fraction, but it's just a division problem. Keep in mind, whenever you see the fraction bar, in essence, it means division. So I'm dividing the top fraction by the bottom fraction. So the first thing I'm going to do again is just rewrite this as a multiplication problem, which means I'm going to really want to multiply by the reciprocal of that second fraction. So this is a squared minus 16 over a plus 2 times the reciprocal. So we're looking at a squared plus a minus 2 over a squared plus 3a minus 4. Again, I would always suggest write it out first, then start factoring, because now our factors actually aren't that bad. A squared minus 16, that's difference of squares. So a plus 4, a minus 4. And our denominator is already fully factored, a plus 2. Again, multiplication problem, so we can basically just write it as one big fraction. So a squared plus a minus 2. I know I have to start with my a's. 2 is a prime number, so we can only use 1 and 2. And if we're going to get a +2 or +1 in the middle, but still -2 when we multiply, we're going to want a -1 and a +2. A squared plus 3a minus 4. Again, nice prime number to start with. 4, again, we could do 2 times 2 or 1 times 4. Which one of those factors have a difference of 3? And we're going to use the 1 and the 4. So I would want to do subtract 1, add 4 to make that +3a in the middle. So now we can go through and cancel our like terms or simplify our like terms. So we have an a plus 4, a plus 4. We have an a plus 2, a plus 2. We have an a minus 1, a minus 1. And the only thing we're left with was the a minus 4 in the numerator. Again, technically, if everything was simplified out, we still have a 1 in the denominator. But what's anything divided by 1? So our final answer, a minus 4. So again, go ahead, pause the video, and try out example 5. Okay, here we go. Last problem, rewrite as a multiplication first. So this is really x squared minus x minus 2 over 4 terms. So we're going to have to do a factor by grouping on this one, times reciprocal, so x plus 3 over x plus 1. So again, I'm going to do some side work because the 4-term polynomials take a little bit of room. So let's see here, x cubed plus 6x squared minus x minus 30. Group them up. First group, I can take out an x squared. Oh, can I do a factor by grouping on this one? Huh. Is there any way to make that next term actually an x plus 6? interesting. I can't factor that one anymore. So I must be able to stop, right? Don't forget that's not your only expression. So let's go through and see if the other things factor. Now let's see, we have an x squared minus x minus 2. I can factor that expression. That's an x and an x. 2 has your terms 1 or factors 1 and 2. If I do a subtract 2, add 1, I'm there. The only thing that didn't factor was this denominator, and that's okay. Just because one piece factors doesn't mean we just stop. Check your other expressions. I am still going to write it with parentheses around it, though, to make sure that I'm keeping all of those terms all together. So again, multiplication problem now, so I can just rewrite as one big fraction. We have an x plus 3 and an x plus 1. So we can actually simplify out that x plus 1. So the two ways we could write this out as a final solution, again, depending on who's writing the problem, what application you might be doing this with, we would have an x minus 2 and x plus 3 in the numerator with this whole mess in the denominator. Or you may see it written where the numerator, the factor is left over or multiplied back together again. So that would give us an x squared minus x minus 6 all over x cubed plus 6x squared minus x minus 30. Now be careful. Just because in this final answer we have a minus x in the numerator and a minus x in the denominator, we cannot cancel those. They're not factors. You can only cancel or simplify factors. You can't do it with just single terms. So that would be our final solution. As always, let me know if you have any questions, concerns, or comments. This is the end of Unit 3. So after your practice from this lesson, I would absolutely go back, double check, make sure that if you have any second attempts left on your lesson checks, definitely try those out again. Go back and review your first attempt though, and see if you have any questions to ask before you finish those out before your test. See you later.